Morning, y'all. I just realized that I accidentally forgot to post a video with the slideshow I put up yesterday. Um, so today I'm just gonna add it to the slideshow and then, or I mean, add this video to the assignment as like a supplementary resource so you guys can watch it. And then that'll be all we do for today. And then instead of taking a work day tomorrow, we'll do an activity tomorrow. And today can just be like your work day. Since I messed up, it didn't put this video up. So sorry. My bad. And next week, we'll have Friday work day instead of Thursday. Okay, so let's go over this. Let's go over this slideshow. Is this showing what I want it to show is the real question. Okay, whatever. Maybe it was working, but at least this way I know it is. So, thinking spatially. Let's get the old laser pointer out. We're talking about what we use maps for. Thinking spatially, basically, which is what geography is. It's about how humans inhabit space. So geography is the why and of the where. So when we study geography, we ask questions about places. This class is human geography, so it's kind of specific to humans and how they interact with places. Maps are a great way for geographers to show what they know about a certain area and whether it could be a whole world or a tiny little country or a city or a town or even a map of like a sewer system. The map or a cave, perhaps, or something like that. The map is the where of geography. We already talked about that. It allows us to draw conclusions, make connections, and there's always more questions to be asked about any conclusion. Map projection. This is going to be a question on the worksheet. Map projection is the way we fit Earth's 3D surface, or a globe, you could say a globe, onto a flat paper or a screen. Turning a 3D object into a 2D object is never going to work perfectly. You're always going to lose some dimensions because they're in different dimensions. So the first question is going to be what type of questions can we answer with maps? We're going to learn later you can do population density, economic growth or decline, or how much money people make. You could do a map of how high mountains are. You could ask what direction does air flow, and then you can map that by mapping the winds. You can map ocean currents. You can almost answer any question you can think of with a map, as long as it deals with our world and humans. So distortion, what is distortion? That's what occurs when you try to put something round on a flat surface. You can't do it. One good way to think about it is like peeling an orange and trying to make the peel look just like an orange when you lay it out flat. It's never going to work. So when creating flat maps of a round Earth, we encounter the following distortions. This is on your worksheet. Shape. The shape of certain countries or oceans sometimes can look different. The country may look more wide or long than it truly is. Distance. Some projections cause features to look closer or farther than they truly are. Relative size. Some projections make countries look way bigger than their true size. And then direction. Some maps you can't use, like it won't it won't be true north on the map because it's distorted too much, so you can't use it for direction. So every map is going to encounter one of these distortions, either shape, distance, relative size, or direction. So cartographers make different maps for different reasons. Cartographers are people who make maps. That's their job, map makers. Some map projections are very accurate in some ways and inaccurate in others. There's no perfect map besides a globe, because a globe is 3D. So a globe actually is like our planet. So it can be a perfect map, but you can't put a globe on a piece of paper. And like I said, hard to fit in your pocket. You can have one in your classroom or your house. I don't have a globe. I should get one, but good globes are expensive. So these are some different types of maps. As you can see, this map makes the oceans look weird because it disconnects them. You see Antarctica is one huge landmass in this one. And then in this one, Antarctica has 4 different land masses. So this map is not accurate on how the Earth is shaped, but it is accurate on how the countries are shaped. Each country is about as big as it actually is in the real world, the land masses. This is the map the National Geographic Society uses now. It's a good, it sacrifices in between direction and size in a good way. This is the map that a lot of us use to study in the United States. As you can see, it's got Africa that big and Greenland pretty much even bigger, which in reality, if you look at this map, Greenland's real small and Africa is really big. So that's the different distortions in between maps. Here is one of the projections you're going to need to talk about. It is Goods projection. Goods projection. It is also known as the interrupted map. This is that weird looking one. It is not called Goods map because it's a good map. It's because the guy who invented its name was Goods. Or good. So as you can see, oceans are interrupted and Antarctica's interrupted. But the land masses look good. So that's Goods projection. The Mercator projection. You can see it's got these nice boxes of measurement. So it's very easy to get direction down. You can do right angles really easily in it across the whole globe. So it's very accurate for direction. They invented it as a way to sail across the ocean using just a compass. Perfectly straight line, latitude and longitude, which we learned about earlier. This is the projection a lot of us study in school, the Mercator one. But it's the one where the landmass is really weird. And a lot of people think that this perpetuates imperialist attitudes in North America and Britain, or in Europe, because it makes European countries seem, and North American countries seem bigger than countries along the equator or countries in Asia. Oops, I got the same slide twice. Well, that's because it's got different information. The distance, yeah, so measuring the distance perfectly, it causes extreme distortions in the north and the south. That's why Greenland looks so huge, Antarctica looks so huge. Antarctica is not more landmass than the whole friggin' planet. Equal area projection. This is another one that'll be on your worksheet. This one is this is where size is accurate, but direction is way off. So you can't use this one for directions, but at least every country has a relative size. What we gain in accuracy, oh yeah, and then also they're shaped different. Even though their size is the same, the map looks like it's shaped funny. So. And this is the new one that the Geographic Society does. So Equal area projection is accurate in size, but it is inaccurate in shape. So the pro is size is accurate, and the con is that shape is inaccurate. The Robinson projection is a little bit distorted in all ways. So the con for the Robinson projection is that it's not perfect, but the pro is that it looks really nice. It kind of compromises between losing size and shape and direction in the best way possible. It's most commonly used for informational maps. If you were looking up like languages, you don't necessarily need complete size and distance accuracy, but you want one that's easy to read and understand. So you would use the Robinson projection. It's a very common one. There's hundreds of different map projections. We're only covering the popular ones. But for all kinds of different things, you would use different projections for different. If you were trying to build roads, you would use a different projection than someone who was studying languages. So then there's different types of maps too, not just the projections of them. There's political maps, which are, we'll cover that in the next one. They show government divisions of land areas. So that's the definition of a political map. For example, this one would show country divisions, but it could be divisions between states if we were looking at a map of the United States. If we were looking at a map of Minnesota, it could be counties, division of counties. So it could be any type of political map. Then we've got physical maps. These ones are the ones that show physical features like mountains, rivers, canyons, things like that. Special purpose maps. So there's many different types of special purpose maps. We'll be studying them next. They show data for a specific category. This specific map shows where there's malaria risk and where there is no malaria risk. So the countries aren't named. Doesn't really matter if their size or the projection's not important, right? As long as you get every country on there. So all of these are special purpose maps. Map makers will use them in different ways. Contour maps is definitely more popular than Isoline maps. I don't know, I probably shouldn't have even called them Isoline maps because that's just confusing. So contour maps connect points of equal value. Basically what it is showing you is where there's more lines, there's more elevation. And where there's more space, everything's flat. So in the where there's lines, there's mountains, and it raises or lowers in the level of sea level if it's and then also so basically if there's lines, it's higher or lower than the space next to it. They display how high elevation is, and the more lines indicate how tall a feature is compared to its surroundings. A choropleth. I always struggle with that one. Maps put human or physical features into maps for regions. Basically, you can take a human feature and map it. This one is population up here. Green areas have less population, and then it goes from yellow into red for higher population, so there's more population in these red areas. This is just another type of map. It's proportional symbol. So instead of coloring in a country, you would just put a circle on it, and the more people that live there, or this one's the more people who have internet, it has a larger circle. So more people in England have internet than people, well, it looks like England and Scotland have more internet than people in the Republic of Ireland. This is another type of map. It's much like that dot map before, except for instead of using dots, you use the size of whatever. So this one's the size of each country according to its population. So India is way bigger on this map than it is in real life because it has a bigger population. The United States is larger than India in real life, but on this map, since India has such a huge population, 1.3 billion, and the United States only has 326 million, that means that our country is going to be smaller on this map because the size goes to population. And then dot distribution, I think this is the last one. Dot distribution is just where there's more population, you'll have more dots. So hopefully you can now see what thinking spatially is. You can use maps to think about all the way people interact with their spaces. It's much easier to use a map to show information about regions than it would be to write an essay or explain it out loud in words. So we'll be working a lot with maps, and geographers are always thinking about data and how it corresponds with certain spaces. That's what geography is. All right, rock on. That's the end of the show. Y'all have a good day now. Let's see, can we turn it back on? Peace out, guys. Later.